In the previous section, we described the purpose of a host VI and the basics of creating a host VI. By the end of this module, you will be able to deploy an FPGA VI. Now let's talk about deploying an FPGA VI. So there's two methods to deploy an FPGA bit file. So one is you can use the host to load the bit file. And the way that you would do that is you would have your VI on your host running, and then that would use the open FPGA VI reference VI. And at that point, the VI will go ahead and deploy your bit file. And we'll talk about this more in the next slide. The other way you can do it is you can have the bit file loaded independently from the FPGA flash memory. So you could actually download that bit file to flash memory on your FPGA and have it load from there. So let's go ahead and compare and contrast the two in this section. So on this slide, we have an example of the host reference deployment method. Okay, so that was that first method we described. So if we take a look at the hardware, let's look here first to try to understand it. So notice here we have our host computer, and then we have our FPGA there, and we also have a host VI. Okay, with this method, the host VI is going to use that open VI reference function to deploy that bit file directly to the FPGA fabric. Okay, so at this point, it's using that bit file to reconfigure that FPGA. And then once we've done that, and everything is running, you can communicate between the FPGA VI and the host VI. So the way that you would implement this method is on your host VI, you're going to place that open VI reference function that you see there at the top, and then you're going to configure that function. Okay, so notice that we are in the configuration window there at the bottom, and what we've done in this case is we've selected a VI, which is my FPGA.vi. And because we selected that VI, this function is going to look for the bit file that's associated with that VI, and it's going to go ahead and deploy it. Okay. So one caveat about using this method is this bit file, it won't be loaded and running on that FPGA until after your host OS is already running, and also the application that the host VI that you wrote is loaded also. So let's take a look at that in our next slide. So here we see the timing that's associated with the host reference deployment method. So if we take a look at this, this is kind of a timeline of our host computer and FPGA. So first, we're going to power on our host computer, right? So that's the first thing that happens. Then that host computer, whether it's Windows or an RT target, has to load the OS. And then after that, then we have to make sure that our host VI or host exe is loaded and running. When that host VI starts running, then that's when it's deploying that FPGA bit file, right? And only after that does the FPGA actually load and start running. So in the meantime, so from the time between the device got powered and from the time the FPGA VI is actually running on the FPGA I/O state is uncontrolled, okay? So if we wanted to control that FPGA I/O between those two times, we couldn't do it using this method. Okay, now let's talk about the second method. Now we're going to talk about the FPGA flash deployment method. So let's take a look at the hardware. So here we have our host computer. Remember that host computer could be an RT target or it could be a Windows computer. And we have our FPGA piece that's inside there. And we have our FPGA fabric. On the FPGA, there's also an FPGA flash memory. And we also have LabVIEW and our host VI. Okay, so what we can do is we can take the bit file that's associated with our VI. So we'll navigate to the bit file, and what we can do is we can download that bit file to our FPGA flash memory. Okay, and then we can set the FPGA so that every time the FPGA actually powers on or reboots, it can automatically take that bit file that's already in the FPGA flash and deploy it to the FPGA fabric. Okay, and then at that point, we can go ahead and still communicate between the FPGA and our host VI. Okay, so let's talk about how we would actually implement this method. Okay, the first thing you need to do is you need to configure your build specification to generate a bit file that is set to run automatically when loaded to the FPGA target. So if we take a look at our screenshot here, notice that we have a build specification of simple math. And what we want to do is we want to go to the properties of that build specification. Notice that highlighted in red, we need to go to the run when loaded to FPGA item, and we have to go and enable that. After we've enabled that, that means when we load that bit file to our FPGA, it'll automatically start running. So the second thing you need to do is you need to download that bit file to the FPGA flash. Okay, so there's two methods to do this. You can either use a configuration window to do it, or you can programmatically do this. Let's first talk about using a configuration window to do this. So let's go ahead and jump into LabVIEW and make it a little bit more clear. Okay, so let's take a look at the configuration window to download the bit file to FPGA flash. So before we get there, remember we need to have a build specification, and we need to make sure that the run FPGA on load is enabled. So let's go ahead and check our build spec. So notice that the run when loaded to FPGA was enabled, and then based on this build specification, I've already compiled this with this enabled. Okay, so I'm going to click OK. I've got my bit file already since I've compiled it, and I'm going to go to FPGA target now to download it. So you can right click and go to RIO device setup. And then from there, we're going to go ahead and navigate to our bit file that we want to download to the flash memory on our FPGA. So let me go ahead and navigate to it. So notice that we've got the FPGA bit file subfolder, and we've got our bit file that we have compiled. And when we compiled it, it was already set to run when loaded. So I'm going to click OK. So now that we've selected that, notice that we're connected to our compact RIO here with this IP address, and we can go ahead and click download, and this will download this bit file onto the flash memory of that FPGA. So the next thing you want to do is you want to go to the device settings. Okay, so this is the device settings for that FPGA flash memory. So you can choose three different options. If you click do not auto load VI, then that flash memory is not going to auto load our bit file onto our FPGA fabric. If you choose auto load VI on device power up, what will happen is when I turn on the machine, so in this case if I turn on if I connect the compact RIO to power, then it'll automatically load the bit file and run it from the flash memory. Okay. A lot of times you might want to use the third option instead. So on the third option, what happens is every time I either turn on my compact RIO or I reboot my compact RIO, then it is going to go ahead and take the bit file from the flash memory and apply it to the FPGA fabric, and it'll start running immediately. Okay. The second option, the difference between the second and third option is the second option will only automatically load the bit file on device power up. The third option will auto load it on both power up and reboots. And then after that, you want to click apply settings to apply them. Okay, so let's jump back into the slides. Okay, so we just saw how to use the configuration window to download the bit file and apply those device settings. But what if you had a lot of FPGA targets? Let's say we had like 50 FPGA targets, and I don't want to right-click and go through that configuration window 50 different times. Well, another way of doing this is you could do this programmatically. So there are some VIs that you can download to do this. So there's a download bit file VI, and there's a set RIO device settings VI. And those correspond directly to that configuration window that we just saw. So if you want to use these VIs, you can find them on the FPGA target system replication document on ni.com. Okay, so just go to ni.com, search for that document, and you can download them there, and you can also get descriptions of it there. So one way that I might use this is I might make a Windows VI, and I could put these functions in there, and I can programmatically create some logic that'll go ahead and download the bit files and set these settings for 50 different FPGA targets. Okay, so let's look at the timing for the FPGA flash deployment method. So if I've set that bit file to run when loaded, and I've also set the device settings to load that bit file every time the device gets powered or rebooted, then this will be the timing that we see. So as soon as I turn on that compact RIO, for example, as soon as I turn it on, the FPGA will load the bit file from the flash immediately and start running. So pretty much as soon as I turn it on, it's going to start running that FPGA VI. So that means with that FPGA VI, if I have some logic in there to control that I/O state, then that'll run immediately. Okay, so the FPGA is already up and running, the FPGA I/O state is already controlled, and then we can wait for the the OS to load, and then also our application VI or EXE to load. And then the VI or EXE can connect with the FPGA VI by using the Open FPGA VI interface function.